So the COVID-19 activity from Module 7, it was indicated that the COVID testing is 95% accurate. What that means is that 95% of the time, the test will produce the correct result. So if you have COVID, 95% of the time, the test will say you have COVID. If you don't have COVID, 95% of the time, the test will say you don't have COVID. So we engage in this kind of hypothetical just idea of, let's suppose that 80% of the population does not have COVID. Now this is just a given for this activity. This is not something that we somehow magically know. Just for the sake of this activity, we wanted to suggest or propose that suppose we know that. And under this kind of model of what we're projecting, what would it mean to say that the test is 95% accurate? So 80% does not have and 20% does have. And so the way we can think through this is through what we call the area diagram. So we make a rectangle. This is just a visual representation, or consider it like just a way to help us to think through these kinds of probability problems. So first, I would think about it this way. Let's split the rectangle up into 20% and 80% to represent the 20% that have and the 80% that do not have COVID. Now the challenge here is that if the tests were 100% accurate, well then 80% of the people we test won't have it, and 20% of the people we test do have it, and the story would be over. But all of these tests, from drug tests to pregnancy tests to any other kind of testing situation like this, we know that they're not perfect. And so if there's a 95% accuracy rate, then what that means is, of these 20% of the people that have COVID, 5% of them will come out with an incorrect test. That is, the test will show up negative even though they have COVID. And 95% of the time, the test will be right. That is, the test will come out positive, as it should if they have COVID. So notice what we've done here is just focus on this 20% slice. So that's the new whole. The whole unit is the 20%, and we're saying that 95% of the 20%, or 0.95 of the 20%. So that is, we're going to split the 20% up into 95 and 5%. So when you do that, 95% of 25%, 0.95 times 20% is, I have to type it in because I didn't remember it, 0.95 times 20% is 19%. So, and then 5%, or 0.05 of 20% is 1%. So, let me change colors here just so you can see what I'm getting at. We'll go gold here. So what we're getting at is this. In this section right here, the 5% of the 20%, 5% of 20% is 19%. So of the 20% of the people who have COVID, 19% of them, that's not right. The 19% was down here. 19% of them will test positive as they should. So it's a true positive. But 1% of the people who have COVID, the 5% of the 20%, 1% of them will test negative. So they have it, but the test was negative. So it's a false negative. All right, so kind of likewise on this side, we're going to split it up into a 95% and a 5%. So 5% of the people who don't have COVID, the test is going to be wrong. And the test is going to show that they do have it. And then 95% of the time, the test is going to be right.
So the people who don't have it, the test is going to say you don't have it. The test will be negative. A negative test meaning you tested negative for COVID, meaning you don't have it. You tested positive for COVID, meaning you do have it. So now we have to figure out 5% or 0.05 of that 80% side and 95% or 0.95 of the 80% side. All right, so if you want to just type those in, check my work here, 80% times 0.05 is 4%, and 95% of 0.05 will be the other 76%. So what we're saying is, let me again change the color here. So in this section right here, 5% of this 80% side, the people who don't have COVID, they're going to test positive. So 4% are going to test positive even though they don't have it, and 76% are going to test negative as they should. So this is a false positive. False because they tested positive, but they don't have it. And this is a true negative because they don't have it and the test truly said so. So let's kind of break it down over here, because in this assignment you were to kind of write it up in a chart here. I forget the order exactly I had it, so I'll just kind of go in order here. The true negative, you don't have it and the test says you don't have it 76% of the time. A false positive, that is, you don't have it but you test positive 4% of the time. A true positive, you do have it and the test says you have it 19%. And a false negative is the last one up there. The false negative was the 1%. That is, 1% of the people do have it, but they're going to test negative. Now you may look at this now, and this is just data, and you can take from it whatever you want, and I'm going to put into your comments some things, but just, you might think 1%, big deal. But suppose we tested, 10,000 people. Well, what's 1% of 10,000 people? Think about that for a minute. There's a bunch of people running around that have COVID but think they don't. Do you see the problem? Or there's this group of people who 4% of the people think they have it but they don't. So think about 4% of over a weekend or over a week. I don't know the numbers, but say over a week 10,000 people are tested. What's 4% of 10,000? And how many of those people are false positives, and what might that mean for an individual's life? So the big point here is that if all you read about is the 95% accurate, you're kind of missing all the details about what that means. That there's a 76% in there, there's a 4%, there's a 19%, there's a 1%. Hey, by the way, note that was supposed to circle them all. Notice 19 plus 1 is 20, plus 76 is 96. There's 100% of the people accounted for here, because there's the four things that can happen: true negative, false positive, true positive, false negative. So we should get a total of 100% of the people based on a 95% accuracy of the test. So notice this 95% is about accuracy. Excuse me. Is about accuracy, and these percentages are about the people, this collection of people. Maybe it's 10,000, maybe it's 1,000,000, maybe it's whatever number you can imagine. Whatever number you can imagine, in the long run, 76% of them are going to be true negatives. 19% of them are going to be true positives. Great. But 4% are false positives and 1% are false negatives. Those are the issues, the falses, based on this 95% claim. So there's a lot more in the story than just a 95%. You go, oh, well, that's pretty good. That's a solid A. But a 95% accuracy means more to the story. I hope that helps.